You have everyone? Where's Emily? I'm missing two. Who's gone? Okay, so while waiting, you can attempt those questions on your own first. And I would say I'll stop at question 3 because question 4, I'm going to teach you some technique to draw initialness. So maybe we start that part on Wednesday. So let's finish part 3. So for question 3, it asks you to state what kind of stereoisomerism it involves. So far we've learned 2 types. Okay, if it involves a double bond, you can consider whether it has the what's happening? I'm lost. Cis and trans isomers. Okay, so geometrical isomers. If it got a chiral carbon that bonded to 4 different groups of atoms, then we can consider it to be the optical isomers. So if it's an optical isomers, then you draw the 2 enantiomers. And if it's a geometrical isomers, then you draw cis and trans, or the E and Z molecules. Are they coming or not? Okay, let me go through this question. So part A, okay, let's work out whether it can exist as enantiomers. Okay, so the first one, because it got no double bond, so we will not consider the geometrical isomers. Then let's work out whether it has a chiral carbon or not. Okay, so first carbon, you can see identical, 3 identical hydrogens. The second carbon, 2 identical hydrogens. The third one, again, 2 identical hydrogen carbons. This one, possible. Okay, so let's double check. Well, this carbon, it first attached to the OH group, and then it attached to this hydrogen group, and then it attached to the methyl group here. And finally, on the left-hand side, it's a propyl group. Okay, so it attached to 4 different groups. So this carbon is said to be the chiral carbon. Okay, so it can exist as stereoisomers. Okay, so now we need to draw the pair of stereoisomers.
This is teacher talking. My teacher.
Okay, so for this one, in order to draw it, we need to convert it into 3D diagram. Right, so we draw the carbons in the center, and then we try to put the 4 different groups onto the carbon. Okay, so I usually prefer the longest group on the left hand side, easier for us to draw. Okay, but it doesn't really matter. So the C3H 7. Okay, so that's the propyl group on the left hand side. And then we got the OH group. And then we have the hydrogen, and also we got the methyl group. Okay, so now we have turned this molecule into a 3D representation with a chiral carbon in the center, right? Because we have learned the shape, it should be arranged in a tetrahedral way. Okay, now let's draw the mirror image of that molecule. So for those two groups, it will stay the same, okay? Because remember, the line state that's in the plane. Oh, you can treat it, that's the same plane as your paper. So it will not change position. And then this methyl group, because it's pointing away from you and pointing towards this side of the mirror, so when you draw the mirror image, it will go like this. And the hydrogen, okay, is pointing towards this side of the mirror and pointing towards you. So if you take the mirror image of that, the hydrogen will go like this. So that's how you draw the enantiomers or optical isomers. Okay. How about B? Can B exist as enantiomers? Because it got no double bond, so we would not consider geometrical isomers. Can you find any chiral carbons on it? Yes, okay. The answer is there's no chiral carbon on it. Okay, so take a look. For this carbon, okay, it attached to a hydrogen attached to OH group. But on the left hand side, it attached to the ethyl group. On the right hand side, again, it's an ethyl group. So two identical ethyl groups. So make it achiral. It got a plane of symmetry here. Okay, so we just circle it cannot exhibit stereoisomerism because it got a plane of symmetry. Okay, the last one. Okay, the last one, it got a double bond. So maybe we can consider whether it has a geometrical isomers or not. Okay, so remember for geometrical isomers, similar requirement. So on the same side of the double bond, you should not be able to find the two identical group of atoms. Right, so check this molecule. On the left hand side of the double bond is attached to a hydrogen and then an ethyl group. Okay, so it's okay on the left hand side. How about on the right hand side? Okay, on the right hand side of the double bond, this carbon attached to a hydrogen and also COOH group. Okay, so again, different groups of atom. So different groups attached on the same side of the double bond, hence it can exhibit as a geometrical isomers. And then if we want to draw the two geometrical isomers, again, we better draw the complete structure formula. So the first one can be this. Okay, so for this one, because the two identical hydrogens are on the same side, then we call it the cis, okay, cis isomer. And then the next one, we just switch the position of the two. Sorry. Okay, and here the two identical hydrogens now on different side. So this is a trans isomer. Okay. I think that's enough for today. Do you got any more questions? Okay, try to complete the rest 2 questions before our meeting on Wednesday. Okay, and if you got any question, you can send me a message or type in now or unmute yourself and read and yeah, raise your questions. Okay, yes. Will you switch?